Okay, we are now moving into troubleshooting. This is the last phase of this lesson, okay? And I have incorporated the ladder diagrams and the schematics, the numbering systems, motor starters, control relays. Those all used to be individual lessons for the most part. And I have integrated these into one to help us move further and also to show how they all tie together rather than individual siloed lessons. I think as we've been going along, we've been building a control relay ladder diagram. And we've been adding inputs and outputs, and we've been doing our numbering as we go along. So I felt like if we integrated it, it would make more sense as opposed for you to learn them in siloed lessons and then have to kind of draw it and pull it together. So we've been trying to do that as we go along. So let's go ahead and get into troubleshooting, okay? First of all, when you first approach a system or a machine that's down and you've got a problem, okay? You can use 4 of your 5 senses, okay? There's one I'm going to suggest you not use. But use your eyes, look around, see something that's evidently wrong, okay? I've run up on solenoid coils on hydraulic directional control valves. You know, they've turned toasty and dark and black and just burnt to a crisp. You know, it doesn't take a meter and it doesn't take a lot of diagnosis to figure out what exactly went wrong. Now, you're going to eventually want to know why that failed, but you know, you can find it right off the bat. Use your nose also. You can smell burn things. You can arcing and things like that. You can kind of pick up on that sometimes if it's in the air. Okay, so you kind of use your nose there, to use your eyes, use your nose, listen to things. Okay, you can tell a lot just by listening. Are transformers humming just an awful lot? Are we hearing arcing, things like that? You can very carefully use your sense of touch to feel something, whether or not, for example, whether or not a solenoid is energizing. You can feel it click, or a relay, you can feel it click as it energizes, okay? So those are your 4 senses that I would use. I would kind of refrain from using your sense of taste with any of these. It's probably just not a real good idea. You know, let's just stick with the first 4 that I mentioned. But let's go ahead and move into troubleshooting. Basically, if you keep this in mind, this one factor here in mind, it'll make life a little bit easier for you as you approach things. Number 1, voltage leaves the hot side of a transformer in X1 tap, and it's always, as we've stated before, time and again through this lesson, it's always trying to get back to the neutral side, okay, back to home, all right? So the problem is that there's a breakage somewhere, or there's a component that has failed that won't let it complete that circuit. So that's our job to figure out what that component is and why it's doing that. So if you keep that simple about just returning back to neutral, it'll make life a lot easier. What we're looking for, like I said though, is where the voltage broke down. Where is it not passing through when it should be, okay? We're going to use a voltmeter, and we're going to, when we're using the voltmeter, I always like to reference it to neutral. So if I've come off the hot side and I start going from component to component to component to see where my voltage is being lost, if you'll reference it back to neutral, it's a very safe way to do that. Safe as in not only from harm, but safe as a good steps to take in your troubleshooting process, okay? So let's kind of take a visual look at this, okay? I can do all the talking in the world, but really most of your troubleshooting experience and your understanding on this is not going to come from this, but instead it's going to come from the trainers. And they're actually pretty good, the amateur trainers, wherever they've got them interfaced with the Fault Pro system. You'll build circuits and you'll try to find the faults in them. But here's how you kind of approach that. All right, so we've got a multimeter, and I've got it here on each side of the transformer. I got it on the hot side and referencing it to the neutral. So the 120 volt transformers on the secondary side, I should get 120 volts, okay? Before I do that though, before I put that meter and go to all that trouble, I'm going to use a little bit of common sense, okay? I've got a light here, okay? And usually machines have indicator lights, pilot lights and things throughout to give you some idea of if something's working or if it's in automatic or manual, whatever. But if you've got some type of a light and some indicators going on, you pretty much know the secondary is putting out control voltage, okay? Because that's where all your lighting and your solenoids and stuff get their power from, is the secondary of that transformer. So immediately, if I walk up and, okay, and if we had more than just one run, but say I had that pilot light and it worked, well, I'm not going to go check the primary voltage of the transformer because I'm getting secondary voltage. I couldn't get secondary without primary. So I know the primary is good. I know the secondary is good because I got a light. So I'm not really going to focus too much on the transformer. I'm not going to focus on three-phase fuses or the fuses to the primary. I'm not going to focus on the fuse coming out of the secondary. I know I've got voltage just by looking at it. Okay, so I used a little common sense there, and just what's given to me right here. But let's suppose that we don't have the light. Okay, and that's our problem. So what I'm going to do is I'm going to reference it to neutral. I should get 120 volts, all right? And then I'm going to then go to this point here where my first device in line here is my normally closed switch. I may have it right here, but this switch, we can't automatically assume that we've got voltage on that switch. That switch could be 50 feet away, all right? So, and in between this point and 50 feet away from where the switch is located could be a junction box, could be terminals, wire terminals, it could be wire nuts that have come loose. So we can't naturally assume that, well, it's coming out here, so we've automatically got it here. It could be something in the way here. And your schematics will tell you this, particularly on the construction. They'll show you where all the junction boxes are and all these termination points if they're midway or something like that. But what we want to do is we want to put our voltmeter right here on the incoming side to this normally closed switch. I should be looking, we know that power coming off of the transformer is named number 1, okay, it's labeled number 1. So we should have a wire going into our normally closed push button switch labeled number 1. So I'm going to go to that one, then I'm going to reference it to neutral. Hopefully I've got power. And if the switch is good, I'm going to take my lead, I'm going to put it right here and see that it's passing through. This is a normally closed switch, so if it's here, it theoretically should come right out with no interaction with me whatsoever. So I'm going to measure it right here. And then I'm going to take that, and if I've got voltage there, I'm going to take it and I'm going to measure it right here, because this, again, these two switches could be 50, 60 feet away, we don't know, and we don't know what happens. Fork trucks run over wire all the time and crush it and break it, and just all kinds of things happen. They burn in two as part of the process. Sometimes they're around the hot molten aluminum or some type of a furnace, and so you never know what's going to happen. So you check it coming out of here, make sure that you got it here, and you continue to step through that, looking for the place that the voltage just kind of disappears. Okay, so in this case, I'm going to measure it here and here. I should see on the other side of this normally closed switch, we went in as 1, we came out as 3. I should see a 3, so I'm going to check to make sure that that circuit is intact when referencing to neutral. And then as I come over here, I find my normally open switch wherever it's at on the machine. And then I open the panel or the back of the switch, and I should see a wire number 3 going to the normally open set of contacts on that push button switch. That's the one I want to check because we know it came from here. I want to make sure it made it from here to there. Okay, so as you can see, we're just checking to see where that it's getting to a device, leaving a device, and then doing that with each device downstream. Okay, and again, we're going to check it here and continue to check and reference it to neutral. All right, and that's one of the safest and the most logical ways to do it. Now you can do it backwards to where you reference your meter to the neutral here, and you can start working your way back. Okay, and one thing you got to remember too is I have a lot of students do this. They will blame a normally open push button as being faulty. Okay, they'll say it's burnt open, that it won't close. Well, you've got to remember that in order to get voltage from this side to this side, you got to push the button. Believe it, I'm not kidding. Believe it or not, that happens a lot. And they'll get over here and they'll test a relay, a control relay coil, and they'll say, I'm not getting voltage on my coil. And I'll look at it and I'll say, yep, I kind of agree with that, because they aren't pushing the button. They're getting to here. You got to remember to push the button or whatever it is to complete that path to get here, then measure to make sure you don't have it. So that's a common mistake a lot of new students make when learning how to troubleshoot. Okay, so troubleshooting an input device. We're going to go over this real quick, and data and output devices. Okay, so it's not ours to know why something broke at this point, but we just need to know what it was that broke or that failed to allow the circuit to be completed when we're in the control circuit. Okay, we want to know how it failed and not why so much at this point. Okay, and otherwise, if you don't, you kind of guess, and you just that gets expensive, and you lose a lot of credibility. Input components. Okay, in order to test them, we'll go back here. We want to disconnect them from the power. First of all, we want to make sure power is getting to our input component first. check, see if we get power, and if it's not getting power after we actuate it, yeah, we got the problem right there. So what we're going to do, we're going to disconnect the power from the circuit. We're going to isolate the component from the circuit, and when we isolate, you can just pull one wire off of it, okay, that'll be safe enough. And then, of course, we're going to always do lockout, tagout too, just to completely isolate the power. All right, and then we're going to, most the input devices, they can be checked with an ohm meter, just to see if you got continuity. Again, where the input devices don't convert that electron flow to any type of work, it's just passing it through. So you should get relatively zero resistance, none at all, okay? You should read very close to zero. All right. On sensors, they're more difficult, particularly electronic sensors such as photo eyes, proximity switches, and things like that. Those are going to be a little bit different. But for the manually operated or the automatic device that just has a set of contacts that opens and closes, yeah, you can use a control. I mean, you can use a multimeter to check to see if that control device is working or not. Okay, you'd be able to use it with the ohm meter. Okay. Likewise with outputs, they're very similar to checking input devices. A little bit different though. We want to first of all make sure power is getting to our output device. Let's make sure that the switches are actually delivering the power before we decide this is bad. If power is right here, okay, if power is right there, we want to start checking it. Okay. So how do we do that? We disconnect the power, and then we isolate the component. Now we'll also use an ohm meter to check this. However, you should be reading some amount of resistance. This will not just pass it through. This is, for example, on the relay or the motor starter coils. Okay, if they've got quite a bit of winding in there, and so it's got some resistance because of the length of wire it takes to make a coil. So if you remember, some of you had the meter reading quiz in 1001, I think it was. And I had you read the resistance of a control relay coil. It's about 113 ohms of resistance. Well, that's a lot more than just a switch passing the voltage through. That was relatively no resistance. But the long length of wire that it takes to make that coil, and you wrap around and around, it adds resistance because of such a long length of wire. Okay, but when you take it out, you isolate the power, and then you want to check to make sure that it's got the proper amount of resistance. Okay, if you put your ohm meter on there and you read nothing between your two coil leads, you've got an open in your circuit, and sometimes if you have a shorted circuit, that means that the coils have come in contact, the insulation on them have rubbed together, and instead of going the full length of the coil, just like water, electricity is going to find the path of least resistance, and wherever it's shorted, that's where it's going to bail out of that coil and go to neutral. Okay, so you have shorts and opens, and with the output device, and you can have the shorts and opens with the input devices just as well. Okay, like I said, I can't really do a whole lot as far as teaching the troubleshooting with the lecture here. The biggest thing that you can do is to come in and lab and work with these, and we have them connected to the Fault Pro systems. We're going to try to get those integrated into the next lesson, but we want to save plenty of time for your project. So anyway, that covers this lesson, 4 components to it. Hope you got something out of it. Like I said, it's been a lot more material in here. That's the way it was designed, just because we're trying to combine and integrate several concepts into one. I felt like this is the best place to do it. So with that being said, I hope you enjoyed it. If you've got any questions, by all means come see me in the lab or my office. I'd be glad to help you. And good luck as we start moving forward.